because ice. We all know ice floats. Most people, if you say, draw a floating ice cube, they will draw it like a floating cork, with most of the ice cube just sitting up on top. Because when you think of floating, you think of floating. You don't think of something that has only a little bit of it floating. You think of it, most of it is floating. Ice floats with only 10% of its volume sticking above the water. They knew this when they drew the scene. So when they pull the ice cubes out, that's how big they are. And I measured this, and it's basically a tenth of the volume. Okay? This is why icebergs are hiding most of what they are. This is what makes icebergs especially deadly for ships, such as Titanic, which we will visit later. Frozen water, you take H2O and freeze it, it's a density issue. It becomes less dense than water and it floats. A profound fact in the history of life on Earth, because most things, when you cool them, they shrink and become more dense and then sink. Ice, when you shrink it, it becomes less dense and floats. Which means in the winter, as you freeze a lake, the upper surface freezes, but it does not go to the bottom. It stays there, insulating the water below from the cold air above, thereby not freezing to death every single fish in a lake. It's how aquatic life survives the winter in all the major bodies of water that freeze over the winter. So this is not just a simple fact, it's a profound fact. And if you squeeze, this is also why your pipes break in the winter. The water freezes if you let water in them. It's also why you can ice skate. You skate on ice not because the ice is slippery. You skate on ice because the pressure is squeezing the ice to less than 10% of that extra volume. It cannot stay solid if you squeeze it to less than that volume. It will instantly liquefy, returning to the state of matter from which it came. So that as you skate over ice, you are melting a bead of water under your blade, and you're gliding on water, on the ice, not on ice. And it's all traces to this act. So now, that's not even why I'm taking you to this movie. That's a trivial point, which is whether ice floats. Let's get to the action here. Ready? Ice person here is ready to do her thing. Ready? Here she goes. Oh my God! Did you hear what she said? Oh my God! My soul is spiraling in frozen fractals. A Disney princess is singing the word fractal. Oh my God. Fractal. Here's a snowflake. So snowflakes are not perfect fractals, but it's very Mark Twainian in my sense that the idea is sound, that you zoom into any one part of a snowflake, and the structure in the small part of the snowflake, just as there is structure in the larger view of the snowflake. And fractals have nested structure all the way down, as close to it as you can observe. And in fact, if you looked at any of these little leaf appendages, and you zoomed into that, you would see structures that resemble the very snowflake itself. You can construct fractals of any kind. Here's one. This is like a tree fractal. So there's the tree, and then every branch of the tree is an exact replica of the tree itself, except smaller. And then every branch of that branch of the tree looks just like the tree again. These are fractals. It is a well-known mathematical construct, and you can have computers generate them. Here's one. And they're very beautiful. So you step out and you see all of these, and then you can step in. I don't have a laser pointer, but if you look at this sort of grouping above my hand, that grouping is the same as this entire grouping. Can you see that? And so, fractals manifest in some aspects of nature. One of my favorite is in a vegetable. Any gardeners out there? What vegetable am I thinking of?
Romanesco broccoli.
Cauliflower. What kind of? It's actually called Romanesco broccoli. Here it is. This is fractal food. Anytime I have a math party, I serve Romanesco broccoli. My wife spent her formative years in Alaska, and last time we visited, her friend had a whole garden and was growing this stuff. This came from her garden, and I photographed it. So this is like my personal photo. And so I made a print of it, and it's now hanging in our kitchen. It is. So if you take a look at it, if you zoom in on it, let's zoom in. It's the same thing. And it's a pattern, and it spirals in the same direction. So we have fractal food growing in nature. There's also, you can pretend fractal. Like here's somebody who pretend fractal the dog. Okay? Here's how that goes. Isn't this completely creepy? You been having nightmares tonight? Now, if you were scared of the flying monkeys, this is not going to bother you at all. So these are fractal dog ears. Let's do some more mathematics. Let me remind you that that symbol, a sideways 8, is infinity. And once again, we visit a beer commercial. This will not be the last of the scientifically literate beer commercials. In physics, there's something called surface tension. And I had a whole thing in here, but it would have taken too long, so I'm just going to gesticulate what's going on. Surface tension is a property of a liquid. And you have all these molecules freely moving in a liquid. That's what makes it a liquid. If the molecules were not freely moving, we would call it a solid, of course. So they're freely moving, and there are forces that attract them to one another. But if I'm a molecule, oh, you can't see over here. Right. Ready? There are forces attracting them. You guys can see in the upper
Oh, yeah.
Okay, so you feel forces pulling you in every direction. So the molecules basically, they can go in any direction equally. But as you near the surface of the liquid, there aren't molecules above you to pull you in that direction. So the net force on you is downward towards the other molecules. And so in fact, the surface of the liquid creates a kind of a film of molecules. It's the same substance. It's not a film like a separate material. It's just that the surface has a certain kind of tension to it, which is why you can have insects. So there's like a, in fact, is it a spider? Well, water spiders. Water spiders can walk on the water. And one of them is like called a Jesus spider or something. Yeah, Jesus is in there somehow. With some water, okay? But I assure you that whenever Jesus walked on water, it was not surface tension. That was holding him up. So you have surface tension, and that's how it works. Okay, so it turns out that you can measure the strength of surface tension and compare it with other forces around you. If you are a tiny bit of liquid, then the surface tension is strong compared with the weight of that liquid. And the surface tension can actually win. This is what happens when you wax your car and then it rains on your car. The water beads up and creates these little walls. Why doesn't it just drip off? Surface tension is winning. That's how you have beads of water. This is winning surface tension. But if it's large, then the weight overwhelms the surface tension, and then the bead just collapses. So, this will matter, because once again, we go to a Disney movie, this time Pixar. We go to the film A Bug's Life. In A Bug's Life, there's the nerd ant. You remember him? And this is back when you could still abuse nerds. Can't do that anymore. Because we know how to fix your computer. One day you come knocking on our door. The balance of power has shifted over the decades. The football quarterback has to think twice about who he's slamming into the lockers. So let's join in our nerd and see what inventions he has up his sleeve.
Invention? Yeah, I've got something for you too. Please, Jimmy, coming soon. Use this to oversee production. Dr. Clark, if I may. Just ordinary blade grass and a bead of dew, right? Wrong. It is in fact a telescope.
Very clever, Flake.
Oh, Princess, my arms are looking lovely this morning. Of course, we need a telescope to see that.
Okay, I don't know if you caught all the dialogue there. So he took a bead of dew, and if you're as small as an ant, the dew just keeps its spherical shape. It doesn't weigh enough to flatten itself out. He puts it in a rolled up blade grass and makes a telescope. Again, there's a Mark Twain extension here. Holding aside the fact that the ants are bipedal and speaking English, telescope can actually require 2 lenses, not 1. So we have to get a smaller dew and put it in the bag. But I'll give him this one, all right? Because they went all surface tension on the scene. There's another scene, for me, my favorite of the film. This is where, they're being bullied by the grasshoppers. So he goes to the bar to get, it's like the bar scene where all the roughnecks hang out. You want to gather some people who can protect your tribe. It's almost a cinematic trope. We've seen it in many films, including the Seven Samurai, the Magnificent Seven, the same movie, of course, but different cultures. There was also Star Wars, right? Luke goes in to get people to protect him, and then Han's Solo shoots first. So we come to the bar, we come upon a mosquito, and this mosquito orders a drink. Clearly, what drink is the mosquito going to order?
Blood.
Bloody Mary, of course. So here's the mosquito ordering a Bloody Mary. Does it come in a glass? It doesn't have.
Excuse me? Hi, I represent an ant colony, and we're just...
Hey, bartender, Bloody Mary, old pasta.
Sir?
That's it! Okay. Somebody knew about surface tension. Otherwise, they would have served it in a glass. And then he would have sipped it out. He might have put his beak in the glass. Beak, whatever the ant's thing.
Proboscis.
Oh, proboscis. Excuse me. With entomologists in our midst.
Hey.
I work at a museum that has entomologists. I should have asked them what they thought of Bug's Life. Were they frothing at every scene, that we can't stand? Ants walking on